Hello everyone, welcome to 𝘎𝙬𝙎 classes. So I welcome you all to another 360-degree MCQ series for your GPAT, DI, NIPER, all the pharmacist related exam preparation. So the topic of today's MCQs will be interfacial tension. So let's start with our first question, and I would like to inform you all that you will all have to mention your scores in the comments below so that even I can assess your performance, and let's see what else is actually required. Any doubts you all have, that we can definitely cover up. Okay, so let's begin with our first question. So we have our first question right here. The question says, Wilmy plate method is used to measure what? See, we are talking about the surface tension, interfacial tension, right? So the first question be very simple with us. That is, Wilmy plate method is used to measure what? So it is very simple. You all will be able to easily guess that it is for the surface tension. I'll tell you one simple trick to remember all these methods. Number one trick here is Wilmy dropped CD and ring in tension. Wilmy dropped CD and ring in tension. So it is easy for you all to remember. Wilmy means it is talking about the Wilmy plate method. Dropped means we have drop number method. We have drop count method. Okay. C here means is the capillary rise method. Okay. Second D here is the drop number, and secondly was the drop weight method. And we have ring in tension, that means ring detachment method, right? Do you know ring detachment method? So these are all the methods you can easily cover using the simple trick Wilmy drop, CD and ring in tension. Okay, so we have option B as the correct answer. Okay, moving on. Contact angle is reduced by. See, whenever we study about the contact angle, it is very simple to say that contact angle is actually inversely proportional to the wettability. Wettability of what? Wettability of surfactant. So it is easier to say that the contact angle will be reduced by the wetting agent. Okay. So more the contact angle, poor will be the wettability, lesser will be the contact angle, more will be the wettability. Okay. Next question. Surface tension is usually defined as the change in the surface free energy per unit change in length, area, volume or density. See, it is a very simple question. By definition also it is understood that what is surface tension? Surface tension is nothing but force per unit length, right? Force per unit length. They are here talking about the surface energy. So we have multiple ways by which we can express our surface tension, right? So while we are talking about the surface free energy, definitely they will include nothing but the area. Okay, right. So we have correct answer as option number B. Okay. Next, here again it is simple value based question. What is the surface tension of oleic acid at 25 degrees Celsius? For water, everybody remembers that it is around 72 degrees Celsius. For oleic acid, this question was asked in GPAT 2024, right? So it is around 30 to 32.5 dyne per centimeter, right? So it is a direct question. Option number D here will be the correct answer. Next question. HLB value of surfactant for the wetting action. See, very simple. Surfactants, the HLB value, the easiest way to remember the trick is ODS. Okay, ODS. So this ODS means this A, that means the first three will be the anti-foaming agent. 1, 2, 3, the ones with the HLB number 1, 2, 3 will be the anti-foaming agent. Then we have water in oil emulsifiers. Then we have our wetting agents, right? So here it is safe to say the wetting agents 1 to 3 anti-foaming, 3 to 6 will be around this one, and then we have 7 to 9, right? So wetting agents will be around 7 to 9. Then O will be oil in water emulsifiers, D will be the detergents, right? And this S will be the solubilizing agents, right? Please remember this table usually lists from about 1 to 20, right? But there is one surfactant which is an exception, that is sodium lauryl sulfate, that has an HLB value of around 40. This is an important question. Okay, please note it down. So I think we have our correct answer without any doubt. All right. Next, which of the following is the nature of SLS? You all have seen the HLB values. Okay. So you have seen the SLS is nothing but sodium lauryl sulfate. Now here, because all these are actually the types of surfactants which are given in the option, you can see the cationic one is there, the anionic one is there, right? So these surfactants can be categorized generally as the anionic ones, where basically the anionic part is responsible for the surface active property. Then we have the cationic, then we have the neutral ones and the amphoteric ones, of which the action will be definitely pH dependent. So because the SLS, now you must remember there are multiple examples we need to learn while we have to cover the surfactants example. So one simple trick is there, that just remember AIIMS, right? AIIMS, ATE. All the AIIMS will be for the anionic surfactants. Number one, they are included in the class of alkali soaps. Just remember this, and most example are from sulfates, benzoates, right, sulfonates. So you remember 8, that will be the example of the anionic surfactant. For the cationic ones, we have AIIMS, right, benzalkonium, pyridinium. So AIIMS, so it is relatable that we are talking about the cationic surfactant. For the neutral, actually we have spans and tweens. We have spans and tweens. Okay. Last, for the amphoteric one, the example is lecithin and dodecylalanine. Lecithin and dodecylalanine. These are the least, I can say, you must remember. It's a very important concept and you must remember the examples. See, for the amphoteric ones, it is clear that yes, the action is supposedly based on the charge and at what pH it will get ionized. The examples are lecithin and dodecylalanine. For the neutral ones, we have spans and tweens. For the cationic ones, it will end into pyridinium, benzalkonium, right, cetyl trimethyl ammonium bromide. So we have AIIMS. Anionic, alkali soaps, we have sulfates, sulfonates. So the question is asking regarding sodium lauryl sulfate, ATE. So we have our correct answer as option number A. Okay? Yes. So moving on to our next question. The question says MRB 52 is. So again, it is a direct question. A lot of times this question has already been asked. So in the upcoming slides, I will tell you a trick to remember the other surfactants, so you all can easily locate that we are talking about this surfactant or not, right? So it is polyoxyl 40 stearate, right? You can directly write it down because it is mostly asked directly, right? Okay, moving on. Zeta potential is used to determine surface tension, interfacial tension, stability studies or kinetic profiles. See, zeta potential is actually potential difference between the two layers, right? Generally these two layers which are separated by the charge, correct? So we have these charge for the purpose of stability. Generally the particles are interacting with each other based on their charge. If the particles have similar charges, they will repel each other. If the particles have dissimilar charges, unlike charges, they will attract each other. So for a stable formulation, what we require, that particles are kept dispersed, so that we can say the particles may repel each other. The repulsion is more preferred, that is indicated for a better stability profile. So this zeta potential is an indicator solely of the stability study, right? So based on the attractive and repulsive forces, if they may ask you the question, so you may tick that repulsive forces are much more better. Okay. Next, HLB value of tween 80. See, we have already seen the table where I have written down the ODS, anti-foaming agent, water in oil surfactants, then we have wetting agents, then we have oil in water surfactants, right? Water in oil surfactant, ODS, no, right? So then we have oil in water, then detergents, and then solubilizing agent. So tween 80 generally falls in the category when we are talking about the water in oil emulsifiers, right? I think I got confused here. I'll write it down. It's for the oil in water emulsifiers, right? ODS it is. Okay. Anti-foaming agent, then water in oil emulsifier, then wetting agent, then we have oil in water emulsifier, then we have detergent, and then we have surfactants. So it falls here. Okay. Fine. Moving on. Polysorbate is an example of which surfactant? See, we have already seen. Now, some students may get confused. Oh, ma'am, you have earlier told us that 8 means that it is an example of anionic surfactant, but not to fall here, right? I'll tell you why. Because the non-ionic surfactant, you must understand this classification first. Non-ionic surfactant, mainly important, we have spans and tweens. Alright, the spans actually are the sorbitan esters, right? Their actual name stands with the sorbitan esters, while the tweens are the polysorbates. Okay, so don't get confused. These are none other than the non-ionic surfactant while we are talking about the polysorbates, which are tweens, right? Also remember, the tween is actually a hydrophilic surfactant. Tween is actually a hydrophilic surfactant. Span is a hydrophobic surfactant. Okay. These are some important points you must note down. Okay. Option D here is correct. Next, chemical name of span 80. So, once we are talking about span, it must be clear now that we talk about the sorbitans, right? Sorbitan esters, while the polysorbates are tweens, which complete name is the polyoxyethylenes. These are tweens. Okay. Now, one more trick you must remember before that. Non-ionic surfactants include hydrophilic ones, which are tweens, hydrophobic ones, which are span. Okay. Here we have to remember their further names classification also, nomenclature based on the number of carbon atom. We have LPSO. This L stands for the laureate, P stands for the palmitate, okay, S stands for the sorbitate, stearate, and O stands for the oleate. So now on, if somebody asks you about the span 20, that means they are talking about the laureate. Span 40, palmitate. Span 60, stearate, and span 80 is oleate. So we have span 80 as mono-oleate, right? No, this is a polyoxyethylene. We have to see the sorbitan, right? So we have mono-oleate, which is the sorbitan one, right? Option C here is correct, right? Or the first one would be tween 80, right? Okay, moving on. Type 1 adsorption isotherm is explained by, right? So generally the adsorption isotherms are actually derived from our Langmuir and Freundlich isotherm both. If you remember some basics about it, we generally talk about the material, that how much, suppose this is a solute, right? So how much, this is an adsorbent above which how much solute is actually adsorbed, right? So that is explained by a relationship between X by M and pressure, right? So as soon as you increase the number of the molecules that form first they form a monolayer. Okay, so that these relationships are actually explained by both Langmuir and Freundlich isotherm. A complete detail I will discuss in the surfactants video. You all can watch it because we have 5 types of surfactants and it depends that how many molecules are being adsorbed at the surface. For example, initially if you increase the pressure, the number of molecules that will bind here, adsorbed here, that will increase, right? So we have a plot like somewhat like this. Okay, so initially it increases and then a saturation phase begins whereby it is no longer depending upon the pressure. So this all will be discussed in the thunderstorm. So wait for the video, right? Okay, so here option D is correct. Next, Drave's test is used for. This question is like a favorite question. Okay, so for basically the efficiency of a wetting agent, we say efficiency of a wetting agent, this Drave's test is used. Okay, so I think it must be clear by now that option A here is correct. Okay, direct question it was. Next, surfactant used in ophthalmic preparations can be tweens, can be sodium lauryl sulfate, can be both, or can be sulfonates. So basically for the ophthalmic use, we generally use the non-ionic surfactants. Mainly these hydrophilic surfactants are used, okay, which are polysorbates. Okay, tweens are polysorbates, hydrophilic in nature, non-ionic surfactant LPSO 20, 40, 60, 80, laureate, palmitate, stearate and oleate. Please remember these details. Okay. Next, anti-foaming agents act by. We have just seen in the HLB values that all the surfactants based on their HLB values, because surfactants contain both hydrophilic groups as well as lipophilic groups. So surfactants do one thing correctly, right? Which is what? Which is to reduce the surface tension. This is the main phenomena by which the surfactants actually work, which is to reduce the surface tension. The question was easy: increasing the surface tension, increasing the solubility. However, if the question was not relevant to the surface tension, if they may ask you about tween, because it is a hydrophilic surfactant, it can actually improve the solubility. Okay, but in this case we say that it reduces the surface tension. All right. Next, so this question is definitely based on the calculation of the HLB values, and I will first write the formula. I have already can see that it is based on the required HLB values. So required HLB basically means that fraction of the first surfactant into the HLB value of first surfactant, okay, plus the fraction of second surfactant into HLB value of the second surfactant. Okay, then this is the required HLB. So here it says the HLB value of first surfactant, which is tween 80, is 15. Okay, let's suppose the first one is X, right? Then the value is 15 and 4.3 for the span 80. So if one is X, other will be what? Other will be 100 minus X, because we consider the proportion here to be 100%. So generally if they mention equimolar concentrations of the surfactant, so we write 50-50%. So let's suppose here we have one as X and other will be your 100 minus X, right? Then we multiply it, HLB value of B which is 4.3 and the required HLB of 12. Now I think I have put up an equation here, so you all can solve. It will be 12 is equals to 15x plus your, it will be 430 minus 4.3x. Now it is upon you, you all can solve. Let's suppose you get the value of x as your 20, then the other will be your 100 minus x, which will be your 80%. Okay, so that's how you can calculate it and comment down the answer. I am leaving it on you all, right? And then I'm just trying to show the answer, but I will wait for your responses as well. So we have our 72% and 28%. I have already told you the formula, how you can put the values. We got a simple equation. You can solve the value for x and then we can get 100 minus X. Next question again on the tweens and spans, they are quite famous. Okay, so we have sorbitan monostearate, right? Sorbitan, you remember, spans, polysorbates are tweens, right? So we have LPSO 20, 40, 60 and 80, right? So we have monostearate. So the stearates ones are 60. We have span 60 as our correct answer. Okay. Next, same is for the tweens. Tweens are polyoxyethylene sorbitan esters or polysorbates. So we have twin LBSO 20, 40, 60, 80. Polyoxyethylene monolaureate. So we have laureate which is twin 20, palmitate is 40, stearate is 60 and oleate is 80. I hope you can all spot the correct answer as option number A. Okay. Next, which of the following is a non-ionic surfactant? I think now it is easy for you all to answer. We have seen the categories. Okay, still let's cover the other one as well. Okay, so we have SLS, sodium lauryl sulfate. Okay, that is an ionic surfactant. Cetyl trimethyl ammonium bromide, right? That is citramide, which is another cationic surfactant. Then we have our non-ionic ones, spans and twins. Option C. Next, complete wetting occurs at a contact angle. See, I have already told you contact angle and wettability are inversely proportional, right? Contact angle and wettability are inversely proportional. If you increase the contact angle, the wettability is going to reduce. So, complete wetting will occur if you have your lesser contact angle. Okay, so it will be around 0. If the angle increases, it will lead to first partial and then incomplete wetting at around 180 degree, right? So we have incomplete wetting at your non-wettable condition at 180 and complete wetting condition at 0 while being partial at 90. Okay, so that's it. We all have covered our answers and I hope you have enjoyed the explanation. You can comment down your suggestions and feedbacks. Thank you so much. Have a nice day.